Now that a few more people have walked in, are there any announcements that anyone has, or any questions, or any jobs or anything like that people have, or anything? Okay. As we were saying before, the MySQL User Conference is April 23rd to the 27th. That's a Monday through Thursday in Santa Clara, California. If you are thinking of going, there's a $200 discount until March 15th, I think, somewhere in the middle. It might be March 12th. In the middle of next month, and there's also a user group discount for registration, and I can see what that is and get the codes and whatever for that. So today's topic is MySQL Security, and here's a little overview. We're going to talk about the access controls lists. That is what usually people think about when they think about MySQL Security: test databases, anonymous accounts, OS files and permissions. And we're also going to talk a little bit more about some of the more advanced things like the data flow in your application and where people might be able to intercept things, SQL injection, and also cross-site scripting, which, much to the happiness of many people, is called XSS, not CSS, because CSS already has a few different meanings, like cascading style sheets. Thank you. So XSS is the abbreviation for that. So we're going to start with access control lists. Who has access? This is select user host password from MySQL user is how I usually look at who has what. You want to make sure that you see similar passwords, host names that are allowed from like %, which is everywhere. Using the show grant statement, show grants. Using that, you can get information for the show grant statement. If you want to see what people have as permissions, you would do, show grants, from Sheeri at localhost or whatever, and you would find their grants that way. But there's no way to there may be a way to get a list of just everything. But this is what I usually do. I do select user host password, get that, and then I can see, the care user on localhost. What does that have permissions to? You want to be sure that you look out for people with the super privilege. You want to make sure that there's at least one person with that privilege, because that allows you to go in and do maintenance things, particularly when max connections is reached. People with a super user can actually log in. You can have one extra person beyond max connections, and it has to be someone with the super grant privilege, and they can go in and kill processes or whatever that's trying to kill the system.
That's available even if someone's already logged in with super privileges?
Well, there can only be one of them. So there can be, let's put it this way, there can be any number of them, but if max connections is set to say 1,000 connections, you can actually have 1,001 connections. So that last connection, that 1,001st connection, can only be by someone with the super privilege. Some people actually change the root username from root. When you start out, root has super access. Some people actually decide to change the username. You can if you want to. You don't have to. It's just one of those things that if somebody is trying to sniff out passwords and they see that your port's open, they might try the username root and they might try the password. So if you make it a little harder for them, it's going to be a little harder for them to do those kinds of attacks. But again, this overlaps with everything because should they really be able to even get to your network? Everything kind of overlaps. If your firewall is letting these things through and it shouldn't, then that's a bad thing. You shouldn't depend on your firewall to always work, but you should have different levels of security. So if your firewall isn't supposed to let the people in and then it does, then of course you want to have a secure root password and all that kind of stuff. And then there's the anonymous user, which again comes in when you first install MySQL. The anonymous user is basically everyone, and what that says is, for like Unix, it will take for Windows also, it will take the environment username and just log in as that. And so if you have an anonymous user, anyone can just log in. Now their rights are limited. We'll talk a little bit about the test database.
Actually, I had a question about hosts.
Yeah.
How strong is the host checking, or can that be spoofed?
Well, that is a great question. So let's talk about hosts.
Okay.
So a host from percent, the percent is the wildcard symbol, and underscore is actually a wildcard for only one character, whereas percent is more like a star kind of thing. If you want to think of it in terms of regular expressions, percent is dot star, whereas underscore is just dot. Have I confused everyone? Great. So percent, if you have root at percent or user at percent, that means that people can get in from anywhere. Usually you don't want this, because usually that means people can connect from anywhere. If you have an application that's web-based, you probably only want to limit it to a certain number of users, the web users, or whoever the application users are, coming from those web servers. If you have a company-wide application, you want to limit it to those domain names or IP addresses that are company-wide. Usually you don't necessarily want anyone from anywhere to log into your database. If you have percent in your database, you probably don't want it there. Yeah?
If you're using percent.company.com, is it doing reverse DNS lookups every time on that?
If you use percent.company.com, is it doing DNS? Yes. The answer is yes. The way that MySQL does its access controls is every single time you do any command, even if you're already logged in, if you go to the command line, whenever you do a command, it's going to check all this stuff. So it's going to check your username, it's going to check your host name, it's going to check that you have permissions to the table that you're trying to get to, it's going to check to see if you have permissions to the column you're trying to get to. One of the things that it does, by default, is do reverse DNS lookup. And you can obviously spoof that, but you can't. It's harder to spoof reverse DNS. With the skip name resolve option, you can turn off DNS, which makes things a little faster. It doesn't, it makes it a little less secure in that you don't have the reverse DNS lookup. However, it can be worth it to get that speed. And if DNS is down and you are relying on it for MySQL, if you haven't used the skip name resolve, you can actually run into a lot of problems where things take a long time and the connection times out because they can't actually connect because MySQL says, I can't connect you yet, I'm waiting for DNS.
Well, it does. If you have that on, does it do any caching of the names, or is it doing it on, is it going to do a DNS query every time?
Right, so the question is, if you leave skip name resolve out, does it do any DNS caching? I don't think MySQL does any DNS caching, so you'll get whatever DNS caching the machine does. I've actually found it's best to use, in the access controls, I actually use both IP addresses and host names, but I usually skip to just skip name resolve. We have local DNS servers, so again, if you're using skip name resolve, it's how much do you trust your DNS servers. If they get hacked into, then your reverse name lookup isn't really worth it anyway, and how much security are you getting by that? If you think you're getting a lot of security, leave it in. If you'd rather not, do that and say, we're coming from an IP address. Now, one of the things that I have here on the IP address is that these are local IP addresses. So that's kind of, I feel, and I may be wrong, that's harder to spoof. Because you have to have your return address as a local thing, which you really can't do unless you're on the local network. I'm sure that hackers can find a way to spoof that too, but
if they can compromise the routers, then they can.
They can compromise routers. Again, how much do you trust your DNS? You know what I mean? You should trust it, but you should also say, well, if they get in, what do I want? So again, the best thing obviously would be to not allow any TCP/IP connections, and to just allow from localhost. Don't allow from any other host, just allow from localhost. If you do that, that's great. One thing you can do is the -- skip networking option that you see, which means it's a lot faster because it's going to use Unix sockets, or on MySQL. On Windows, it's going to use named pipes or shared memory. If you're going to use localhost on Windows, you need to get the MySQL NT package. I'm not sure what NT stands for. I don't think it's like the Windows NT. I don't know. I just know that you won't get the shared memory without, where shared memory is just a local connection without that package. Again, if you have an application where there's your code base or like a resin server or Tomcat or JBoss or something like that on the same machine as a database, you can do that. If you don't and it's a different machine, you can just allow it from either a block or that one machine. There's no need to allow somebody to come in from anywhere. You could allow from anywhere in the company. You know, the way my company does it is that we require, for root, we require you to log into the machine itself. So I would have to go through a proxy if I wanted to log in as root. The application passwords, you could log in from anywhere on the local network. So, you know, it's a little bit more security and stuff like that. We're not too worried about, I'm the only DBA and I have systems background, so they're okay with me having, you know, root on the box and having a shell login. But there may be times where you don't want to give the person, you know, the DBA or someone who needs to connect to the database even, you don't want to give them shell access, but you do want to give them MySQL access. So it's all company policy, and, you know, make sure that you have your policies in place in your runbook before you even start installing MySQL, which of course we all have. The other thing is that your firewall should also enact any of these rules. Your router and your router should firewall off any, if you say, well, I only want to connect it from localhost, port 3306 shouldn't even be open. You know, your router shouldn't allow anything to go through to 3306, because if it's open, it can be DOS'd. You know, if it's going there, somebody can just packet flood it. And they can packet flood your router too, but, you know, you want to be cautious. People are running port scans, you know. You put a computer on the internet and it takes, what, like 7.5 minutes for it to start getting port scanned? So you want to make sure that people don't necessarily know what's on your machines, if you can. So now, what are people doing with their controls? Now, obviously, you have your grant statements and you're granting select and stuff like that. If you don't want people to load data from local in files, which means that they take stuff that's on the client machine and put it onto the server by going through the MySQL command line, you can start the server with --local-infile equals 0, which means they can't do load data local infile. You can still use the concatenation operator or source in the MySQL client to source from the server side if you're on the server, but you can't use the load data local infile. Another thing is skip symbolic links. It's usually a bad idea to symbolically link to your databases, meaning that the data files that MySQL is looking for is actually a symbolic link somewhere else. I know that MySQL on NFS partitions is very unhappy. I wouldn't recommend it.
Isn't anything on NFS partitions very unhappy?
Well, yeah, I mean,
text file is okay.
NFS partitions are usually a bad idea. But for low loads, they're suitable. Another thing that you can do with the grant statement is you can grant max queries per hour, max updates per hour, max connections per hour for a user at a given host. So you can say somebody can only run 20 queries per hour, or 10 updates per hour, or they can only connect 5 times per hour. The one thing to note about max queries per hour is that that does not include cached queries. So if someone's doing the same select over and over and over and it's actually cached in the query cache, it's not actually hitting the database to say, okay, increase max queries per hour.
What happens when you exceed the limit on max queries per hour? It comes back with an error, or it just hangs?
What happens if you can't exceed it? I believe
No, when you exceed it.
when you exceed it and you can't do it anymore, do you get an error? I do believe you get an error. I don't know what it is. I'll see if it's obvious, like says you can't connect for another 40 minutes. I think it says too many connections for max connections per hour, but I don't know about max updates or max queries per hour.
Is it updates, does that imply inserts as well, or is it just updates?
I think it's all DML. I think it's inserts, updates, deletes, but I can check that.
I can look it up. If you haven't explicitly set this, does that assume you don't have any limit?
I haven't what?
If you haven't explicitly set it, does that assume there's no limit?
Correct. If you have not explicitly set it, there is no limit. Besides the general, like there's a max connections parameter and things like that. So yeah, if you haven't set it per user, there's no limit. Some server options that kind of relate to this security stuff. I already talked about skip name resolve a little bit. bind address will bind it to a certain IP address. So if you have two IP addresses on the same machine, let's say you have two host names on the same machine, a.company.com and b.company.com, you can actually say that the MySQL port should only be open on one of those. Say the IP address is 192.168.0.1 for a.company.com and 0.2 for b.company.com. You can actually bind the address to 192.168.0.1, and then if you try to connect to MySQL on b.company.com, it won't work. So that's actually really useful. It's also useful if you're using MySQL D-Multi, which is the multiple instances of MySQL on one machine, and you want to have 4 or 5 different hosts. This is what we use in our development environment, so that we can simulate different machines without having to actually have different machines. So we don't use it for load testing, but we will use it for separation of databases. In our production environments, we have certain databases on one machine and certain databases on another machine, and we want to make sure that when we're writing code, that we're not just assuming this database is going to be on this machine. And then skip show database. Before MySQL 4.0.2, show database would show you all databases. After that, and currently, it'll show you only what you have permission to do. So before MySQL 4.0.2, there was actually an option called --safe-show databases that would do that. Since then, there's skip show database, which means you can't see it at all. If you type show databases, you won't see anything, even if you have permissions to see it. So if you decide not to do that, you can then, if you do skip show database, you can then explicitly give that power to people. So if you want root to still be able to show the databases, they still will be able to do that.
So you mean it would be turned off for root, even for root?
I believe the super privilege kind of encompasses a lot of things, but I can look that up. But yeah, you would have to explicitly give it to people. I don't know if root, because it's a super user thing, I don't know if it's special,
okay.
but yeah, you would be able to explicitly give it to people. And then the other thing is, when ACLs change, how are they audited and when do they happen? If someone leaves the company, do you change your passwords? Well, sure, maybe they can't get in through the firewall, but shouldn't you change passwords anyway? When someone leaves, and whether or not it was their choice, it's just kind of one of those company policies. And how are they audited? There's some great. There's a poor man's query profiler out there that uses TCP dump to kind of sniff all the packets and decode them and see what's coming through. There's also something called MySQL Sniffer, which is on hackmysql.com, which does a similar thing. So you can kind of use those programs to kind of audit it. One of my little dreams when I eventually get around to it, but I'm certainly willing to share the idea with you, and feel free to make one of your own, is to basically have an auditing kind of a system where you have a box that sits somewhere on the same network, and it sniffs the packets. It doesn't intercept them. It just says, okay, where's this packet going to this machine at this port? Show it to me. I'm going to decode it, and I can see, okay, this person is trying to change password. Put that in a log somewhere. Maybe you will ignore the selects, or maybe you won't. But to get things like, CISP compliance or Sarbanes-Oxley or HIPAA.
That's exactly what our product does.
Exactly. And people have products that, you spend $50,000, per appliance or whatever to do.
We do it for a variety of databases.
Oh, great. What company do you work for?
Kritzer systems.
Kritzer Systems.
And the data that we sniff when we collect is stored in the MySQL database.
There
We
you
don't
go.
actually sniff MySQL. We don't support that, but we support Oracle DB2, Sybase, and SQL Server.
Yeah, I think I used to work for one of your competitors, Guardium.
Yep.
Yeah. So, and when I asked the CTO if they would support MySQL, even though they were using embedded MySQL database.
Not enough, unfortunately, not enough business for us yet. We're still too new a company to
Yeah, and I think
support that platform yet.
I think the regulations are also so new that people would. When I talked to the CTO and I said, hey, why aren't you supporting this? And he said, well, we're just not going to, because people who need this kind of auditing, buy databases.
Mm-hmm.
And I said, well, yeah, except for, I've worked at a university, and, sometimes you just kind of throw a database at it, and oops, hey, now it has some healthcare information because it was for the medical school, or now it has somebody's social security number in it.
But they're also not willing to buy a product that's sniffed as much. That's the other problem.
Well, they're not willing to buy a product, they're not willing to spend, $50,000 to $100,000 on an appliance, but they might have to.
Yeah.
So it would be worse
We're
if they
saying
would.
that TJX had us in trialing the product and didn't buy.
Yeah.
They said they didn't need it right now. They were covered.
Well, there you go.
Until they get sued.
Our marketing department is just open arms with that one.
Yeah. So TJX is if you heard about TJ Maxx getting losing your
No fault of
database.
ours. They literally had the product in and decided they didn't need it.
And
Well,
this-
would that have prevented that though? Because they did get. I mean,
It would have caught it.
oh, it would have caught it. Because one of the problems was that their
Prevented,
passwords
no.
were in the clear.
Our product is after the fact, but
Right.
it would have caught it quickly.
Yeah, it would have caught
It would
it.
have set an alarm off it pretty quickly if you had things set up correctly.
Well, now they don't
Right.
need, all the data's been stolen already.
It would have set an alarm as the data was, as it was monitoring the traffic.
As opposed to having customers call up and say, I think there's something wrong with my account, and then have that by critical mass of people. That's days and days gone by where you're like, wait a minute, what's going on?
And the that amount of data,
Slow
it takes a
down
while
too.
to
It
steal
would
that
slow down,
over
it may not have prevented it. I mean, the idea behind
Well-
packet snippers is you don't want to interfere with the traffic, you don't want to slow down what's happening.
Takes that
It's
long.
after the fact. If you
Probably
detect
still
a
in about
pattern
a
of
minute.
behavior that's clearly wrong, someone downloading massive quantities of social security numbers or credit card data, that's
Right.
not a normal thing that would occur.
Yeah, but even so, how long does it take for that much?
Depends on how they set the system. They can send an email alert immediately.
But even with that massive amount of data, if they're just getting social security and credit card numbers, stuff like that, it still might be a matter of minutes for it
Depends on their upload.
to.
Yeah,
Right.
it really-
Or really,
it's
what you
still
have
a
is an automatic system that says, hey, somebody's doing this thing, let's
Stop
stop
it.
it.
Yeah,
And then yell
then
for
you might
help.
have,
Yeah.
then you've got a fighting chance.
Yeah.
But
Can you
even
do
that
actions with
guarantee,
with
it's
Not
not
at the
done
moment.
before.
at the moment?
Other than sending an alert or an email or something like that, we don't interfere with the traffic.
Yeah, but it's easy for a customer to take that and
Right.
funnel it into a program that goes chunk.
Yeah.
Depends upon what latency there is in the alert, but anyway.
Right. But yeah, the compliance regulations don't specify what to do. They just specify what you want to catch.
Right.
And I mean, even for regular, auditing and monitoring for your own company, you want to know what your DBA is up to.
Right.
You want to know, well, do they really mean? We actually had an incident once where the previous one of the previous IT guys before I'd come on had told people that we couldn't give any more admin accounts out because there wasn't enough room in the database. Now, first of all, these things weren't even stored in the database; it was HT access. But everyone, of course, customer service was like, "Oh, I'm sorry. Should we take somebody out of it? Should we do?" So sometimes you want to know. People have these ridiculous things, and sometimes you just want to know what people are doing and what things are changing. If you have a billing system, you can't delete anything. If you want to void a payment, you got to make a negative payment that has a type of void or whatever. You can't change any of that data, and you wouldn't want to, just because you would want to have a clear paper trail of what happened to something. So, anyway, any other questions about auditing and monitoring? Great. So why do we want to get rid of test databases? Who cares if the test database is there? Now, the test database is something that any user that can log into the system has permission to add tables, drop tables, and that kind of thing. This also kind of speaks back to the anonymous user thing. If you have anonymous users, then everyone can get to the test database. But they're a good idea to get rid of, not just because people say, well, people might copy tables from production, it might have sensitive information. Well, yeah, that's true, and hopefully on your production databases, you're not copying things to do, analysis of, because you're going to interrupt the user experience by doing that. Everything's going to be a little slower if you do that. But even on test or dev systems, much like an anonymous user, if somebody needs a database, give them a database. If they need scratch space, give them scratch space. If they need, you don't need the anonymous user, because if you really need, a whole bunch of people to have an account, use a group username and password. Something that more than one person has access to. The biggest thing I think biggest reason to get rid of the test databases, in my opinion, is that if someone can log in, they can just make DB tables and MyISIM tables and stuff them with data and render your table spaces unusable, perhaps render your entire server unusable if your data is in like varlib MySQL or user local MySQL. If everything's on one partition, or you end up getting something on the root partition, you may find that you can't even log in because it can't write an entry to var log messages. Or it can't do anything because the disk is full. So even just stuffing a whole bunch of data into a table, you may think, well, who cares? Test database, who cares? Well, they can bring down your system.
The database, when it comes out, I don't really pay attention to it. Does it come out with auto increment? To increment the size of the table space automatically? I would think it wouldn't.
MySQL does not come the default etc my. There is no default etc my.cnf, so there are no default table spaces set up. I mean, there's small my.cnf and whatever, but there's nothing that gets directly installed there. But that means it's even worse because with MyISM it stores directly onto the disk.
Right.
So they can render your entire partition useless, and if your entire partition also has your log files on it and your backups on it, you might kind of be screwed on that. And if it also has, if it's on your root partition or whatever, you may end up doing that.
And even about the disk exhaustion, presumably they could set up queries on your test tables that take forever.
Correct. They can. Yeah, right. So the comment was they can, even if they can't, regardless of putting data in the database, they can run a query that'll take forever and slow down your system.
Still, by default size of 4 gigs per table for 32-bit machine with big modern disks, it is not. I know you have to have like maybe 100 tables to fill it out.
Well, if you have one big table, if I just stuff a lot of data into one table.
No more than 4 gigs. Unless you alter that
and then what happens?
intentionally.
Do I crash MySQL? Do I get an error? Can I?
No, when you fill out the table,
Right.
it will return error. No,
Right.
sorry, no.
And what if I have an DB table space and I fill that up? Then it fills up the table space for potentially the whole machine, unless I have file per table. It could potentially.
Doesn't DB allows you more than 4 gigs?
Yeah,
It does.
You can keep growing and growing and growing.
It does.
How
Right.
it addresses so
It
that?
can either, well, there's two things. If you have auto extend on, it'll keep
That's
growing.
the way I
Ah.
think about it.
If you don't have auto extend, then you'll fill up your table space and you can't add anything into it, and you get the too much space or
Create
something.
more extensions, more.
Table space, you mean
Files.
like one table only, not.
I mean the EnoDB table space, where if
I
you
see.
have not
Okay.
specified EnoDB file per table, that is one file space per table,
okay.
then you actually run out of space in the table space, even though there may be plenty of room on disk. Although again, that's a good security tip is use EnoDB file per table. Put limits on it and stuff like that. And of course, use other systems to monitor your disk, and monitoring who's logging in, and monitoring how much the change of used partition, how much space is used from the last time you checked. Do a percentage check. If you start seeing the disk start going way up, maybe there's a monitoring system out there that can check that and say, okay, well, you used to use this much, now you're using that much. That's a really big increase.
You can actually automatically purge, like every day, that stuff, like using events or something.
You can automatically purge that kind of stuff, but why not just get rid of the test database? I mean, people are going to put a lot of crap in their systems anyway,
Yeah.
and it's going to be crap that they need. So you might as well give them their own personal kind of temporary place to play around. You don't need this sandbox that everyone can play in. Everyone can have their own sandbox. They can share their sandboxes with other people, but there really isn't a need to have that. Just because if somebody does end up getting in and you allow this test database or a sandbox for everyone, then if somebody does end up getting in, then you have a problem. I was reading, Bruce Schneer has his cryptogram, and the cryptogram for January linked to an article that talked about a guy who at an airport jumped a fence. He climbed over a fence and got onto a plane and took a nap for 3 hours. People were complaining, we can't even get 3.5 ounces of toothpaste on the plane, and yet this guy comes in and takes a nap. Well, yeah, you're securing so much on one side, you forget about the other side. And again, if he was able to jump the fence, he shouldn't be able to get on the plane. So it's kind of like, if they are able to get in, they shouldn't be able to get in. But if they can, they shouldn't necessarily have the power to do this. And yeah, there are ways to clean it out if you have developers or QA people who are filling up your space a lot. Yeah, that's a great idea. But again, no need to have this public sandbox.
Yeah, I want QA people.
So operating system files and permissions. What you run your MySQL server user as. This is not only important because if you compromise the MySQL server, if the MySQL server is compromised and it's run as root, then you compromise root on the whole box. But it's also important because whatever the MySQL server user is, you want it to be able to read the etsy.my.cnf, you want it to be able to read the data and the logs and stuff like that, because it has to read and write to those things. So if you make it a user that has a lot of permissions, if you make those things world readable, you want to make sure that either nobody's on that box, or you don't want to make it world readable. You want to make them only readable only to the MySQL server user itself. Now you may need to give your database administrator login access. You may need to have them be able to log in as that MySQL server user, or give them root of the box. Again, company policy will kind of dictate what to do. Hopefully there are already some policies in place with operating systems in general.
The good part about running the MySQL server as MySQL user is that if someone does compromise the MySQL database, they won't be able to write to things like varlog messages, which may have forensic data in them, to say someone's been doing a dictionary lookup, dictionary hack at this account and finally got in, and you may actually be able to retain IP addresses and things of that nature, at least to tell if it's an internal and external attack.
That's true.
And even if MySQL is, completely runs amok, at least it won't be able to write to some of these critical system files that may help in forensics later.
Yeah, they won't necessarily be able to hide their trail. The other thing is, if you have, say, a web server and a MySQL server on the same box, let's say you have a web-based application, and let's say you have your passwords in plain text in the database because you didn't know any better when you started, or let's say actually you don't have them, let's say you have it encrypted, your code may be able to decrypt them, or maybe it's credit card information that you're storing to use again later because they're recurring billing or something. If the application code has the decryption in there, and they break into the MySQL server, you don't want them to be able to get both the code and the database. You want them, if they get the database, fine, now you've got the encrypted information. You don't know how we encrypt it. So that's at least one more kind of obstacle in the way. Of course, if you don't encrypt that information, then it doesn't really matter. Using passwords on command line, you probably don't want to do that. If you are just kind of playing around with your database and you type the password on command line, it's possible. First of all, anyone looking over your shoulder will be able to see it. It's also possible that people doing a process list on that system can see it. Many modern systems exit out or don't show it at all, but you might as well just take those extra 5 seconds to type in the password on command line. And of course, if you have a script that runs, you're doing backups on a backup script, what can you do? You want to make sure that it's locked down.
Sheeri, how do you handle errors in scripts? For example, you change ACL, passwords, whatever, and you got an error in script. How you handle that?
Well, it depends. I mean, one of the things that we'll do is we'll run scripts out of cron, and we check cron's mail. So if we find that error back in cron, we'll say, oh yeah, we just changed that password yesterday, and now this script today failed. The other way we do it is by documenting. We document what scripts are out there. We document that every week this script runs, and every day this at 2 p.m. this script
I mean,
runs.
like you try to change a user permission through scripts, and it fails.
You try to change a user permission through scripts?
Yeah, you don't do that.
No, we don't. I mean, why would you need a script to do that?
Maybe I don't need, but we have unfortunately at work people who do that.
Do they do it in large scale?
Not very
ways?
much, not very large. Sorry, but they do. And the question is, that's why I try to convince them not to do that. Why we cannot do that? It's not a problem. I mean, it's just the commands.
That's why you need your auditing system to see who's changing the passwords, right? If they do that, things that I've done in Perl or in Shell, actually mostly in Shell, is you can use -VV on the MySQL command line. So you can do like MySQL -U whatever -V. -E will give you,
command
in quotes, your command.
Yep.
You can also do -VV, which will be a very verbose way of getting it, and so you'll get the 2 rows affected, that kind of thing. There's also -T, which gives something similar to like the output as it would be on the, when you go into the thing.
For example, if you do that through Java, you have error handling
right.
capabilities. Error, you kind of
But you have to throw the error. I mean, the same thing in anything.
But how you react on that error with script?
You tell me. What do you want to do if the password change wasn't successful?
Just
theoretically, they could check for every row that they update. So instead of having a SQL script that updates 30 ACLs, they write one row, is it a clean return? They write another row, is it a clean return? They write another row, is it a clean return? And then they'll have a point at which they can optionally roll back or at least tell you how far it got.
At least, yeah, at least.
Unless, of course, the script dies because
Notified.
they can't actually connect to the MySQL server itself. I mean, there's all this kind of, you have to do lots and lots of testing to make sure that when you do get an error back, it doesn't stop the whole script. But yeah, that's more of a programming thing. Well, what do you want to do when you get an error? So, yeah. Yes?
Related to this, if you have scripts or other programs that have to connect to MySQL using password, is there a standard practice for doing that, or storing the password somewhere? Or?
Is there a standard password for storing scripts that have to interact with MySQL? Yes and no. I mean, we use Nagios to monitor a lot of stuff, and one of the things we use Nagios to monitor is a database, and that gets the password for that. You know, we just have a user that is allowed to log in, and that's it. They can't see any databases, they can't see anything. They have grant usage, and that's it. And that password is stored in the Nagios configuration file, which is kind of where it needs to be. So there's kind of standards depending on what you're using. If you're writing your own scripts, it depends on company policy. One of the things you can do is you can put the password in the script itself. One of the things you can do is rely on the environment variable to use like a .my.cnf for certain, connections. And it's a trade-off. If you use like the .my.cnf, if that gets moved, if somebody says, "Oh, this shouldn't be there," and moves it out of the way, or then you lose on that aspect. If you have it in scripts, each individual script, then you have to worry about what happens when you change the password. Now you have to remember all those places where you put the script in. Maybe you have something that only runs monthly, and you're going to have to wait a while to find out that failed, and you may not want that to fail. So it, again, depends on what your company policy is. So I usually put it in the script just because I don't want to think I have to look somewhere else for the password, because sometimes I'll move a script to a different machine, and I wouldn't want it to break if it moved to a different machine, but there's definitely value in having to only password protect one file instead, protect, not necessarily password protect, but lock down one file, the .my.cnf, instead of all of them. So, all right. Your backups. First of all, how do you take your backups? If you take them over an unsecured network connection, if you don't use encryption on the MySQL connection, then all of your data is going over in clear text. So you want to make sure that when you're doing, or when you're copying, if you're not using, if you're using some kind of FTP protocol to copy over backup files, well, things are going through in clear text. So again, this is one of those, everything kind of overlaps. You could be totally secure and then run your backups over an unsecured connection or FTP, or email your backup files somewhere, and the world can see them. Also, backups are a place where you would end up storing a password, or running it as root or something. Etsy my.cnf, my.ini for Windows people, and the .my.cnf files. Etsy my.cnf, that might actually have a password in it. It might not, but it does have all your settings. And if you can't read the Etsy my.cnf, you can't start the proper instance of MySQL. You can start an instance of MySQL without Etsy my.cnf, but you won't be able to use any DB tables or anything like that because you haven't set up any of those variables. So it's not like they can't start up MySQL if they can't get to it. Of course, if you take the MySQL D server binaries and protect them, then they can. But again, another reason to have the MySQL user and to lock things down is the Etsy my.cnf just should not be world readable. It doesn't need to be. It should be readable to maybe you could have a group of the people of the DBAs so that it's group readable and they can read it. But there's no reason that just randomly anyone who can log into the system should be able to see that. There's a lot of command line interface tools as well as GUI tools that will store your password for you conveniently. Some of them will even do it in plain text. Some of them, there's one out there that does it like, they're stored in an XML document because everyone loves XML. Well, yeah, but that's plain text, and they're not encrypting my password. Your choices there to figure out, how is it storing it, and maybe you just won't store your password, or maybe you store it, but not on your laptop that, might be compromised if it's stolen or whatever. There's a lot of things to think about with this kind of stuff. Anytime you type in your password, you not only have to think about, I'm on a Windows box, maybe there's a keylogger, but you have to think where's this all going? There's also the personal history files, the .bash history, that kind of thing, as well as the .mysql _history, which is really great if you're on a Unix box. You can hit up and get your last command, and it's from wherever the client is. So if you're on a network and you connect to one machine in one host, and then exit and connect to another machine in another host, and you hit up, you'll get your last command, even though it was on it was on a different machine. So that's actually a very useful thing to have, that history file. But if anyone else can see it, then it's not a good thing. Now, the bash history and MySQL history by default are, owned by only the owner. So, but again, you want to, one of the things that you can do, maybe you're looking to see if somebody did something bad. You can look in their MySQL histories. You can look in, if you're root on the box, you can do that kind of stuff. Yeah.
It's a little depressing that MySQL seems to be like 10 years behind the state of the art of handling passwords at all. And you can clearly wrap in something like Kerberos or SSH so that you can only get there through things that don't require you to send passwords along connections. But is there any progress in actually wiring that into MySQL so that it doesn't have to be wrapped?
I know that in 5.2 they're working on, Kerberos integration, LDAP integration, all that kind of stuff. So yeah, that is kind of annoying, but they are working on it, and that's one of their biggest complaints actually. So if you ask them, they'll be like, yeah, we know, we're working on it. So yeah, I mean, they're 10 years behind everyone, right? They started in 95, 92, something like that. So they're pretty good for fledgling 15, 20-year-old company. That's amazingly enough, they announced that they're going to go public soon, eventually. Yeah. So they talked about the fact that they're going to go public. So that's exciting as an open source company. So anyway,
it is not kind of behind. The original intention of MySQL was not for the big, large companies where the password and all of that stuff is kind of big deal. Most of people started to use it just for themselves and for small things where password technique was not kind of really important. In a lot of cases still, nobody uses privileges with MySQL, just set up and go ahead.
Right, and a lot of people are using plain text passwords in their applications. Well, it's only a newspaper, who cares, if it's stored as a plain text. So there are, that doesn't excuse the fact that the database should have it.
No, it's...
But certainly, how many people would not take advantage of that if it were there? And MySQL was founded on the principles of being fast and lightweight and easy to use, and 15-minute install. So certainly, they weren't thinking about Uber security, or like we were talking about earlier, data cubing. They weren't thinking about those things when they started. So they are now, though. So how does your data flow? Let's say you do encrypt passwords or credit card information. Where do you encrypt it? Do you have HTTPS connections if you have a web application? Do you have some kind of secure proxy layer in there? An SSH tunnel that's encrypted, all that kind of stuff. Where is stuff encrypted? Even a simple login form, when was the last time you went to something that wasn't necessarily your bank? You go to, the New York Times. Is the login form encrypted? Probably not. It's probably not HTTPS. I mean, there are plenty of places that I go that I, enter, LinkedIn or Friendster or whatever, where, you don't have an HTTPS login. Some people give you the option of that.
Or the RSVP for this meeting.
Or the RSVP for this meeting, yes. But if you want to anonymously RSVP, I have given you admin@sheeri.com, and I forgot the password is guest or something. So if you are worried about that, you can do that. But yeah, you're sending it in the clear.
Well, in
took
for your
eBay
Meetup account.
forever to do that. That's a much higher value target. eBay had most of their logins unencrypted by default.
Yep.
For many years when they first came up.
Yep.
And people moved real money through eBay.
And even sites that have like, oh, click here to do HTTPS. How many people do you think actually do that? Now, it might not be. Sure, eBay actually has money transactions. But who cares? Who cares if someone steals my New York Times password? Well, if it's a password I use at my bank, too, because I don't want to remember too many passwords, then you have a problem. I mean, we've seen this with the whole, like the TJX thing that we're talking about, and, all these things where people's passwords get stolen. It's not that, oh, they stole my password to LiveJournal. It's that my LiveJournal password was the same as, my bank account, and they get you that way. So, if your data isn't encrypted, you want it to be encrypted before it goes over any kind of network. So theoretically, you would have encryption in like a JavaScript layer, because before it even leaves the client, or you'd have an HTTPS tunnel, right? You'd have some kind of secure tunnel, like HTTPS or an SSH tunnel kind of thing, where it's encrypted before it even goes over any network pipes. Where do your errors go? If the database is unavailable, what does the user see? Does the user see, do you catch your errors in your application code? It's more of a problem if you have the general public seeing your errors, but you may not want someone even inside your company to see those kinds of errors. You may want, the errors to just say, oops, there's been an error, call this person. You don't necessarily want them to know that the database wasn't reachable, or that it was too slow, or, that it's offline or something. You just don't necessarily want to give that information out. You don't want your, PHP errors to go right to the browser, especially if you've put debug information in them. And where does the traffic flow? We were talking about backups before. Who gets the information? What do they see? If you're on an unencrypted connection and you're retrieving sensitive data, that's another thing. Forget, logging in and putting my password in. Maybe that doesn't matter. But if I'm getting other people's sensitive data, well, that's important. It's important to think of where is everything going, and where is it encrypted and where isn't it encrypted. And that's something to think about when you think about things like, well, should I use, MySQL's SSH encryption? Which MySQL, you can use the SSL encryption for the client. If the server allows it, you specify in the client whether that client itself will connect securely or not. So you can still connect insecurely. I don't know if there's a way you can turn off secure connections or not, insecure connections, or unsecure connections, as it were. So yeah, get out your little network diagrams and figure out what are people looking at and where are they getting at. Your administrative applications are a great example of this. If you have the same data but in a different interface, well, now maybe it's all in company, but maybe your company isn't all in one location. Maybe it's still going over the vast internet. Do you have underground pipes going from Los Angeles to New York, or are you going over the regular internet? Reporting. You're doing report. Are you emailing reports out? Email's not exactly that secure. People don't think about this. Maybe your database is perfectly secure, but you're emailing out people's social security numbers in a report because the CEO wants to see something like, whatever it is. Well, that's not necessarily database related, but again, if your database is doing reports, where are they shown? In a web browser? Are they shown, are they emailed automatically to someone? What are they doing? VPN is another thing. If you don't trust your VPN, then somebody can get into the network and, get onto the, machines and go into the tables and do all the things that we're talking about. So it's all very, very intertwined. And the last note here, it's public versus it's easily accessible. This is more of a privacy issue than a security issue. There is a lot of information that's publicly available. Whether or not I voted in the last election, not what I voted for, but whether or not I voted in November of 2006 is publicly available. So just the point is, just because it's public doesn't mean
even
I
selling
want
your
to be
house,
accessible.
you can find it on internet. When did you sell it, and for how much?
Right. Right, but
And that is a lot of information just
Right.
in one state.
That's right, and just because it's public doesn't mean it should be easily accessible. Think about people who make donations. Maybe people don't want to know that. Especially now with you do your vanity searches. You go to a job and maybe you don't want them to know that you've donated to the ACLU. You have no idea, and yet if they decide to put their annual report online that has the list of donors, it says this person has given $1,000 to $5,000. Well, all of a sudden now you're making that data it's publicly available. Anyone could get it. Sure, anyone could get it if they go down to the Massachusetts Attorney General office at 1 Ashburton Place in Boston, pick out your 990 tax, and see. Sure. So just think about that when you're doing this kind of information. Who does need to see what? You can use views in MySQL 5 and whatever. What do people really need to see? Do they need to see aggregate data? Do they need to see individual records? If they need to see individual records, is it administratively, or is it I can see my records? And log that if you can. Get one of these database boxes. It's worth the 50 grand. The first time you find someone doing things they shouldn't be. Plain text passwords are bad. Plain text credit card data is bad too. A lot of data is bad in plain text. As we've seen even with web searches. Just what you search for in a web browser and associating it with your IP address. You can find out lots of stuff about people just by that. So how do you store your customer logins? Are they stored in plain text? Or do you store the password? Do you store a hash of the password? Do you send the password hash over? Could somebody intercept the password hash and make a form, an HTML form, that is very similar to your login form, complete with the action and sending it on over? And you say, okay, great, I have a post variable that's, password hash, that's blah. I'm fine with that.
What do you mean by send the password over?
What do I mean by send the password out?
Or the hash over, excuse me.
So if you hash a password, in other words, do something to it so it looks different. Preferably you might salt that or something so that it's not just a regular MD5 or something like that. But even if you use MD5 or SHA-1 or whatever, if you send that as the password, let's say I log in and it's going to be really secure. So what we're going to do is we're going to put that MD5 hashing in the JavaScript, and it's going to encrypt it even before it goes over any network connection. So we're going to send the login name and the password hash in clear text to the next page in the website.
That's nothing. You just made the password is now the hash.
Right, exactly. That's the point.
No,
password is now the hash.
In the hash, it's not.
Well, but some people might think, well, I've encrypted it, so what's the problem? So again, what's the transmission of your password and hash? And again, as we were saying before, users may use those passwords somewhere else. So yeah, if someone uses their MySpace password on their bank, and then their MySpace password gets compromised, well, whose fault is that? Increasingly, companies are getting more and more embarrassed, even though they're not companies, they're not necessarily companies that have financial data, although some of them are, that you could really have a problem.
One of the things that my previous company, what they did is they had a key that they stored with the middleware. So the customer login passwords were salted with this key. So if the database was compromised, there were no passwords immediately available, and only the middleware knew how to, with its key, knew how to decrypt that database. And if that key got lost, then all the passwords had to be flushed.
There you go, and that's great for both ways too. Because if somebody breaks into the application, gets the application code, or breaks into the application server and compromises that, then they still don't get the the usernames and passwords of everyone. So it's that double-tiered layer of encrypt it in the database. Don't just send it over and don't just trust it. And also put something else there. Make them have to break into a lot of things, not just one thing. People will say, I had a hard time convincing my partner to always lock the door. We have of the car. We have a 1995 Toyota Corolla. It's got 230,000 miles on it. And he goes, well, who wants to steal it? And I said, well, why make it easy? You know, if they're gonna break into a car to steal it, they'll go and steal something nicer and newer. If the door is just unlocked and they can just hotwire it and be gone with it, then they're gonna take what they can get. So, and if they really want to get into it, they'll get into it. And it's the same with, you know, security in anything. If somebody really wants to get into there, they'll keep trying and trying until they can. But you want to make it, it's your job to make it as difficult as possible. So, where are you encrypting it? As we were talking about before, are you encrypting it before it gets somewhere? Or are you encrypting it afterwards and it's not really any use? If you encrypt it after it gets, you know, you're encrypting it as a database function, you know, you send from, say, a web server, that's a website, from a client side to a website, that's insecure, and that website has an application on it, but then sends it to the database, and it uses, you know, MySQL's MD5 or MySQL's password function or something. Then you're sending it twice over connections that aren't secure before even bothering to encrypt it. And where are you checking? Where do you check that the passwords are valid? You know, like we were talking about the hashes before. If you're only checking in the middle page, then someone could send something to your middle page from their own first page. So that brings us to things like SQL injection, where you want to make sure that you validate user input. Semicolon, \G, \G, those are ways to terminate the end of a line. Double quote, single quote, union, those are all things that can be used at a query. If you just put your user input into a query, you know, saying, okay, well, I want to see if this password matches for the username of blah, and the person puts in the username. Well, if they put in any of these things in the username, it's possible they can do more than one query, or do a query that's different than what you wanted. If you end up having some kind of you know, an SQL injection where they use a quote, and that will terminate the string that you're about to put in for, say, a username, and then they put, you know, quote or 1 = 1, then that password, that SQL statement is going to return true. Basically, it's going to say, you know, where username equals blah or 1 = 1. Well, guess what? That's true, no matter what. Union also is something that, you know, if you union or union all, you can, you know, get more results than you wanted, different results than you originally anticipated. So that's pretty much how SQL injection works. Another thing you want to do is HTML encoding. This will actually help with cross-server scripting. One of the things of cross-server scripting is that people can basically, it's another form of injection really, they kind of put in code that will then be run off another site. It can also be run off, you know, the same site, so it's not necessarily cross-site scripting. People will say, well, it's a misnomer or whatever, but it's stuck. So if you have something like, you know, a username field, and somebody puts in that their username is angle bracket head, close angle bracket, script equals JavaScript, you know, language, whatever, and then starts having a JavaScript thing, you know, anytime anyone, you know, looks up their username, they're going to get this JavaScript code. We actually found in our application, we found people who were putting either as their browser type, so that when you log their browser type, it would log as this, or just in their profile, you know, the little personal ad, they would say, they would have HTML in there. And sometimes they would have JavaScript in there. And it would be, you know, going to this ad site that's a pay-per-click ad site or something. You know, it's not kind of harmless, but I mean, it could be really harmful, you know, to find stuff like that. The stuff we found is harmless. We've also had problems where, you know, a user will use angle brackets just to make like a happy face or something, and then it will kind of mess up their profile. And I'm like, why is my profile all messed up? And I'm like, oh, because you know, use an angle bracket. So you want to strip that kind of stuff out, because you know, you want to be really careful of when you allow users to use HTML, because they can put script in there.
Will you strip it out, or you just quote it?
I'll have to see. I think we just strip it out. We just don't let them use it, just because it's not worth it. But again, you have to figure out what you would want. You know, if it's just a smiley face or whatever, and we strip it out, it's not a big deal. Whereas if we quote it, then it's still kind of, people will be like, well, what's this? If people actually do try to inject like a website in there, people might say, well, I can't click the link, but let me copy and paste it into a browser and unknowingly do that. So we just, just strip it out. Again, it depends on what your company uses this stuff for.
A really sick usage I saw was an iframe with absolute positioning and with a session expired and a username login that looked just like the MySpace login.
Mm-hmm.
So people thought, oh, my login expired for some reason, and then they'd log in again. It was logging to this other site.
Right, and so how did that work? Did somebody put their like username? So when you looked up somebody's username, all of a sudden you were.
It was an iframe that pointed at this other site that looked just like it. So it's just a little bit of HTML code that was relatively harmless looking.
But where was it? Was it on somebody's MySpace page?
Yeah.
Okay, so you went to somebody's MySpace page and it looked like you were logged out because it was an iframe to another page.
Right.
Exactly.
And they did absolute positioning, so it was in the right place. So it didn't just flow on the page. It was.
Yeah. And with
Maybe
all those
Shutter.
PayPal and eBay things, I mean, imagine how easy it would be. You put up an eBay auction or you put up something with PayPal payment, and then you get redirected to a screen that says enter your PayPal information or enter your eBay. Well, of course, I just bought something. They want me to enter my username and password, and
Showing that logging simulators have a history as old as computers.
That's right.
I must get at least 10 phony PayPal messages a week.
That's right. Yeah,
What's that?
email, all
I
those
don't get any
phishing,
of those. I wonder why.
gone phishing. And I can't tell you how many times my Wells Fargo bank account has been. I mean, I don't even have a Wells Fargo bank account. It keeps expiring. I don't know.
I haven't
But,
seen one less in a while either.
Yeah.
I guess they got tired of my closing.
Yeah.
By not.
Well, or you have a really good phishing detector.
Do you
So you're
think
just
that
not
the
gonna-
I'm going-
bank,
this is
site
hot
key
now.
now does
That's-
anything to help?
Do I think what?
So do you think the bank's using a site key does anything to help?
What do you mean by a site key?
Well, like Bank of America now has they assign you a site key,
Okay.
and it's different apparently for most users.
There are
Uh-huh.
some
So-
well-known papers showing that site key is useless. So no, it won't really help.
Is it
But
just
this
like a
is
password,
off-topic.
basically, like another level of password?
A specific site key to actually a specific computer, in fact, to a particular IP address.
So it's a cookie,
Um,
basically?
Well, essentially, it's to make it so that you, the user, would know that you really are on like Bank of America's
And that
site.
you're the Bank of America site, plus also that you're also coming in from a known computer. as well.
Yeah, I have
And so-
seen that. I have an ING Direct account, and if you don't come from a computer you've logged in before, it gives you extra, like, what's your
Yeah.
mother's maiden name again, or whatever. So, yeah, I mean, again,
They make you pick an image that you recognize, so
That's
when
right.
you log in,
Yeah, yeah,
if
yeah,
you
yeah.
don't see that image,
Mhm.
Right.
After-
Unfortunately, it's subject to man in the middle text.
Yes.
agreed, yeah.
yeah. We were to null car 0. Entering nulls and stuff can actually help cause things like buffer overflows. So you want to make sure people won't do that. Also, again, if you're doing equalities and kind of that kind of stuff, it can throw off your whole query. You want to be careful with varchar and spaces, because varchar will take off any padding. Varchar takes off any trailing and leading spaces, or at least trailing spaces. So if you have, Sheeri and then a space, even though you may have intended that space to be there, it may not be there. So someone may say, well, I know my username has to be 6 characters long, so I'm going to put in 6 spaces, and there's some tests that validate that, yes, that's 6 spaces long, and then puts it in the query, and it matches blank. So you have to make sure that, if you're using things like varchar, you want to test for blanks as well as the equivalent of blank, which is space. Or a space, or any number of spaces without any actual, characters that have some kind of symbol on it. I know a company that was actually burned by that when somebody tried to put spaces like their username, and it got in as the username, but then they could never log in because their username was checked for that when they checked it, but not when they originally did it or something. So, yes.
Does it apply to all white space or just spaces?
Does it apply to all white space?
I ran into an issue with this just last week, and I was trying to track down exactly what part of our system was causing problems.
Yeah, I think if you have
Only
trailing
spaces.
tabs or something,
Yeah, only
it'll do that.
spaces.
But I mean,
I think it's only spaces trailing.
Only trailing
yeah,
space.
yeah.
Yeah, because tabs is a special character, and so is like carriage returns and stuff like that.
Only spaces. Yeah.
This trailing spaces stuff sounds like a leftover from punch cards.
Well, it's because of the nature of varchar, because it, it happily, takes a variable length thing, and it doesn't think space is a...
It's also
regular character.
formatting sometimes. So you want to line up, that could be the reason.
Yeah. Anyway, so validate your user input. Save yourself time when you're doing stuff like, validating input. Validate your email addresses. There's an RFC out there. If the email address doesn't match the RFC, it's got to have an @ sign in the middle, and it's got to have at least one dot, and here are the, domain levels. Maybe you don't want to do that because there are new ones all the time. But, there are certain characters that can't be in. You can't have an @ in your username because there's already an @ there, and it's something special. So save yourself time and validate your user input. Maybe that means doing that, trick where you send the information, you to confirm their login, you actually validate their email by sending them an email. Maybe not.
And if you're going to validate things like email address, do read the RFCs. I've seen way too many implementations that believe that plus can't be part of a username, for example.
Yes, and also if you're running a Windows domain, don't put a space in your Exchange server because underscore is not technically permitted by the RFCs. So don't put an underscore in your domain, and if you're on Windows Exchange, don't put a space. Again, buffer overflows like we were talking about before, especially with regards to charset, because if you say, well, I can't have a buffer overflow, I have, I'm only allowing, 64 characters, and my text field only allows 64 characters. Guess what? Your text field allows 64 characters. If you're using multi-byte characters, then you can allow up to double that, which may not be what you want. So if somebody's typing in, Japanese characters or, characters that are multi-byte characters, the text box will happily allow you X number of characters, whether or not they're single or multi-byte. So you need
Plus
to be
some
careful about
joker
that.
can use post to stuff random crap down your throat that your web page didn't allow.
That's right. That's right. Post and get if you're using. I think this is on a different slide. If you're using register globals and you keep that on, read that in PHP. That means that any of the get variables in the get context actually can be used. So even if you don't, make a form to post somewhere, if they have register globals set on, you can actually use get variables, just by putting question mark, variable equals value. Yeah? Did you have a
I was
question?
gonna say the same thing, but
Oh. So yeah, so where do you trust get or post from? I'm so smart, I knew what I wrote on the next slide. Only test it from certain pages. I was talking to a friend of mine the other day, and he was talking about this great, application level firewall, and I'm like, well, great, what does it do? And he's like, well, it only accepts when you have like a get or a post, it only allows connections that have get or post variables from within the same site. So you can't do this kind of like, well, I'm going to make a form on my site to connect to your site with a password or a hash that I already know. So where do you trust your gets or posts from? Do you trust them from everywhere? Do you want to set your HTTP refer, take that variable and say, okay, well, if the HTTP refer was this page, okay. If not, forget it. Because, how many different pages are you going to log in from?
But the refer is absolutely spoofable. Why would...
The refer is absolutely spoofable, but again, it's just one of those extra steps to do. It doesn't necessarily have to be checking through the HTTP, refer. It can be, allowing the, saying to the firewall, don't let anyone access this page unless they're from, localhost. There's all sorts of things you can do. And again, even if they have valid session IDs or valid cookies, that doesn't mean that one of your legitimate users isn't trying to do something bad, or they've hijacked a session. Some person who's not a valid user is hijacking a session. So, even if I checked the cookie and I checked the session ID and there's no way there's always a way. So, where do you trust your get or post from? Just like, you want to put those session IDs and those cookies in because they help you do business, but they also, again, it's yet another step that they would have to crack. And if they can find, if eBay makes it easier to steal their passwords off eBay than off your site, then they steal it off eBay.
I think there was some famous example years ago when Get was more popular, where the Get variables included the price of the item, so you could buy something for a penny by just rewriting the URL and submitting it.
Yeah. In fact, I believe that's how PayPal works. You may have to use post variables and stuff, but if you wanted to pay someone, you could, change the Get or post variable. I think they're post, but you still can change it. I know I've actually used that when I'm, want to quickly make a whole bunch of different items in a PayPal cart.
Yeah.
I'll just copy and paste and change like the description and the amount, and you don't have to like go through the rigmarole of going to the website and saying, make me code for this.
Mhm. But the difference there is, what you want to pay is something you have to tell the system.
Right. And I'm paying as opposed to taking
whereas
money
the system
from.
he's talking about is the system.
Buying things,
The price was on the system, and they were letting it be
Right.
altered at the browser level.
Right. So yeah, I mean, there's all sorts of neat stuff you can do.
Ultimately, if your session is hijacked for something like PayPal, you're going to be able to put in whatever they want for the pay, because you have to have that permission.
That's right. And
Otherwise
so
you can't
hopefully
pay.
you've attached a credit card to it, and somehow, well, PayPal doesn't let you turn off your bank account for it, but that's why you have to be. So you have to be back on your unsecure bank website to be checking your bank account to make sure it's not drained.
Or tie it to a bank account that you don't put much money in.
That's right.
That's the
Yeah.
way it's done. You never link your PayPal to a real put money in.
Yeah. Unfortunately, it's a lot easier to get like a Hotmail account than it is to get a fake bank account. So or just figure now with the
Not
with,
fake bank account.
not a fake one, but
account.
one that you don't put a lot of money in.
Bank of America will give you as many as you want. You
Well,
link it to your regular account, it doesn't cost you
See,
anything.
that's funny because I actually had a problem with a bank that I had to leave because I had a checking and a savings account, and I had set up my ING Direct to take out of my savings, and ING Direct apparently doesn't allow that. They only allow you to take out a checking. But they let me do it for 9 months, and then they must have been checking their thing, and they said, oh wait, that's a savings, we can't use that. And they sent something to my bank account automatically going, where's this is savings, I want a checking, and my bank gave out my checking account number, even though they weren't linked. Which I didn't find out till like 2 months later when I overdrafted on something because, it took that long for me to actually overdraft on it, and I was like, why'd you give out my bank account number? And they said, we didn't give out your bank account number, you must have changed it. So, yeah, hopefully they won't link it like that. So, that's my little rant. Anyway.
Which bank was this?
I don't think I should say. It's not fair. They're, it's the only problem I've ever had with them, so. They're a local bank, so. Using prepared statements. One of the ways that you can get away from the whole SQL injection thing is by using prepared statements. It's still a good idea to validate your input, but sometimes you're like, well, I can't run 70,000 tests all the time. You can use prepared statements, and basically your SQL code looks like this. Select field 1, whatever you're going to select from, whatever tables, whatever, where, and the thing that you're going to put that's user input becomes a question mark. And then what happens is that you prepare the query, and all of the major coding languages have ways to prepare. That's just kind of pseudocode.
And this is PHP, right?
I think PHP is like MySQL_prepare. You have to prepare it's like DB handler. You have to use the DB handler would be like an object, and so it would be like $DBH dash angle bracket, to be like the arrow. But yeah, it's close to PHP syntax, but it's mostly pseudocode. I mean, Java would have a similar thing. You'd make a database object, and you have that prepare the query and then execute it. So one of the things, and I honestly don't know if PHP takes an array or just a list of variables. I don't know if it just takes 2 arguments or the first argument.
It takes an array.
It takes an array? Okay.
Perl certainly does, so.
Perl does. Okay. Yeah, I mean, I don't know if the Java one takes an array or if you just give it a list where the first argument is that. And it depends on the connection.
I have a question. In that case, is PostgreSQL actually do the better jobs than MySQL? Because in PHP, when we connect to the PostgreSQL, we actually create objects like a SQL statement, right? Mm-hmm. Then it execute, then destroy. that query.
So what you're saying is
MySQL just
the PostgreSQL connections always did prepared statements?
Yeah, because to prepare the statement, then execute it, then you can destroy.
Right. It sounds like that's the API that you're using to get into it. Because I know with Postgres you can go on command line and you can type and you don't have to prepare the statements. But whatever your driver, your connection is, if you have the ODBC or whatever the connection is.
Yeah, that's all.
Yeah.
The ODBC has multiple ways to connect. You can prepare the statement, or you can do just an execute immediate with something which is not a prepared
Yeah,
statement.
but it has a better feature.
Is it that the ODBC driver that you have doesn't have that for MySQL, or?
Then have for the MySQL, but when I was working with the PostgreSQL, it does.
Right.
So in that case, I feel more, it's sort of like, I'm a PHP programmer. Basically, I can prepare the statement and then execute it and destroy. So
Right.
it's like always, it's like a package.
Right.
Call the function again and again.
And you can do that for both Postgres and MySQL, right?
MySQL, I haven't done that.
See, there is a package, it's MySQL I, that allows you to do prepared queries and things like that. There's also, it also allows things like multiple queries. One of the things about using semicolon here is that any connection driver that doesn't allow multiple statements, it doesn't matter if you check for this stuff, because there's no way that somebody could put username equals Sheeri semicolon select star from password or whatever, because it only will allow one query at a time. So a lot of that, MySQL has that feature underlying in it. It may be that the documentation on the driver, is sparse, or you didn't see that part or whatever, but I know that MySQL has that, that capability. Maybe it didn't in like 3.23 and stuff, but I know that, the MySQL JDBC connection, I know ODBC, I know PHP, Ruby, all the major ones, Java, all the major ones have, I said JDBC, all the major ones have prepare and execute.
But you can destroy the...
You can't destroy it?
Yeah, PHP with PostgreSQL, you can destroy this thing.
And what do you get from destroying it? What's the benefit you get from destroying the statement?
Basically, you can use that variable over and over again. You don't have to update, it's like iteration stuff and store in some. You can just, after execute, especially for inserting, deleting those kind of statement, you have to destroy that statement. Basically, it's already put into the database.
Right.
Sounds like otherwise you'd be leaking memory.
Yeah.
Well, with MySQL, I don't know if you need to destroy it, because I know when I was reading up on this,
No.
no, but I don't think you need to, because when I was reading up on it, they were talking about how prepared statements were actually faster if you're doing multiple things of the same kind, like you're talking about with this, multiple inserts with just different data, because it's already parsed, it's pre-parsed the query. When you do prepare, it'll parse the query.
Well, then it has to be released in some, it has to be released in some fashion.
It has to be
otherwise
released in some
you would
fashion.
leak. But, I don't know, it used to be like 4, 5, 6 years ago, in the Perl DBI connection, and MySQL didn't really have the internal preparer that were hooked into it, so they actually cached it locally and took care of that, so MySQL never saw the prepare, or they were still doing all the quoting and stuff like that. I don't know if that's been changed in the more recent...
Can somebody look up like the MySQL prepare stuff to see if there's a destroy? I don't.
No, I
think
never
there
seen
is.
it.
There has
So
to
then,
be-
isn't there a memory leak?
But there has to be a way to...
Never seen it.
There has to be, there has to be a way that it's released.
And I
Is it
doubt
possible
about.
it just releases it at the end of the query?
I think it just releases it when it needs, when it hasn't been executed in a while. I believe it's a question of space. It's just like the query cache. It'll keep it around until such time as it doesn't need it anymore.
And I inserted
And
millions
then it will just,
of
get rid of it because it
rows
hasn't been accessed for a while.
with that
Well,
stuff. There is no memory leak. I didn't find that.
In my connection, which may still be active, I'm going to submit an execute. I may submit an execute on that much later. I could be sitting around with something that prepares a statement, executes it, doesn't execute again for another day.
Yeah.
So either there's a protocol to re-prepare it, to go back to the source and say, send me the full statement because I don't got it no more. Or
For days it will break the connection, and after that you try to execute it, it says, sorry, there is no connection.
that's how it's functioning
Yeah,
right now?
yeah.
So SQL has a connection and disconnect key, it's not functioning in PHP. So it's very clear what you do when you actually execute something.
Right.
Even for the statement, you prepare and execute it, it's really clear.
Destroy. Never heard of it.
I'm not sure.
I know that you can. I mean, you can close a connection like you were talking about, like the actual
Yeah.
connection. I know you can do that. I'll look it up and see if it also may just be one of those things that every time there are garbage collection arguments, there's a problem. When do you clean up the stuff? When do you not clean up the stuff? So MySQL may have something by default, or maybe they don't. So I'll look it up. It may be one of those things that's just not an issue. So they talk about how the prepared statements are faster when you're doing multiple inserts and stuff like that. They didn't mention anything about, well, it's possibly slower. I would think it's possibly slower because just preparing and executing, if you're only doing one query, well, now you're sending two things to the database if it's over a
It's
network.
not meant to be used, and if you're going to be
No,
doing it one time.
just more
That's
work.
not the nature of what prepare was
It's not the
designed for.
nature of it, but if people are using it to prevent SQL injection, that's why I'm saying it here, that it's not always faster. But so if you're
It
relying
would
on
be
it,
faster if you're going to do it on a one-on type of thing. It definitely is faster to do and execute immediately without preparing.
right? It's definitely right. So yeah, it's definitely faster to do, to just execute the query itself than do a prepare if you're only doing one off. But then you don't get the SQL injection. You know what I mean? That's what I'm saying is that there is that thing. So if you are doing this and you're doing it for one off, know that you're going to get this problem.
Actually, it's a little more complicated than that, because when you say faster where? Faster on the server or faster at the web server?
I'm talking about total user experience at this point.
Well,
so, yeah.
both of those are in there, because at the point of the web server, if you're just constructing the statement yourself, okay, you have multiple variables in there, you're going to do multiple calls, you're going to do all the coding on the web server.
Oh, that's
Whereas
true. All the checking and everything.
All the coding is going to be done on the web server, whereas if you're doing the prepare, the coding will be done on the database server. So,
That's true.
I mean, the coding is shouldn't be that expensive or whatever, but
you don't need to escape all that stuff. But then you also don't have to worry if there's a new feature that comes out. You don't have to worry that, oh, great, now I have to escape this other thing, and now I have to go and find out in all my code where I have it. So if you prepared a statement.
When I'm constructing statements, I escape anything that's in a variable. I don't care where it came from. So, when I write it, it doesn't matter. It's going to be, even if know that there's no way that this variable could possibly have it in there. Well, if somebody changes something,
Right.
it does. So you just automatically escape everything.
Yeah.
In the
You have to,
variables.
validate all your data and check it all. So the other thing you can do is you can use stored procedures, which also, you can use a prepared statement inside of a stored procedure. And that also helps because you only have to send, you could send the name of the stored procedure instead of the whole query.
My understanding is the stored procedures are parsed every time you access it. Is that so true?
Stored procedures are parsed every time you access them. I don't know about that.
At least from what I read on the first implementation of the stored procedures, they were not pre-compiling it. They were keeping them basically in the original source form and parsing and doing it when you access the stored procedure.
Yeah.
Anybody know about that?
I'll have to look that up. I don't.
I thought there was supposed to be some performance enhancements, actually.
Yeah,
during
that's
the
what I was-
procedure. I
that's
think
what I
there's
was
something being stored. I'm not noticing, we're using stored procedures, I'm not noticing a performance problem with stored procedures.
Well,
The thing about stored procedures is if you want to do this type of thing, you don't necessarily even have to prepare them. You can dynamically generate the SQL statement from the stored procedure. And if you don't want to do a prepare and then execute.
And
skip the extra
actually,
step.
there's only a few things that you can be dynamic with. You actually can't, for instance, in like a cursor, you can't use a dynamic table name. So
No,
what I'll do
you're
is
right.
I'll have a stored procedure that prepares a query, prepares a, either a query or prepares a statement to another stored procedure, and then call that so that I can actually have dynamic table names. So I don't think that's the case now, but I'll look that up. One thing we talked about was encryption. We already said SSL encryption for MySQL is per client. You can't read that, can you? You're all having a hard time reading how to look for unencrypted MySQL data streams? Yes? No? I'll make it bigger since we're almost done. I'll make that a little bit for y'all.
Sheeri, I
Yeah?
kind of surprised that you didn't mention UDFs.
Yeah, UDFs. You could use UDFs. I think I wanted to say that in when I was talking about stored procedures. But UDFs, they're a lot faster. UDFs because they're user-defined functions because you compile it, but you compile it into the server unless it's 5, right? 5. Do you always have to compile it into the server even in 5, or?
There are two ways to do that. You can compile it with a MySQL code, or you can install it using shared libraries. And with shared libraries, it's relatively easy.
So now with shared libraries, you don't have to recompile MySQL. It's just kind of
No, you don't have to. If you follow the user interface guidelines,
Okay.
you just put it into, again, if you know where to. Unfortunately, it varies, even between Windows and Linux, between Linux and Unix, and between different Unixes. It is different, but you definitely can do very interesting things, especially from security point of view.
Yeah.
And you can play with MySQL user account using UDFs.
Yeah. That's That's some tricky stuff. So yeah,
Interesting
UDFs.
thing.
If you want to be elite hacksaw, then UDFs are for you.
Yeah.
But yeah, I haven't done too much with them because there is such a big learning curve. I mean, even stored procedures are just such a you already know SQL, you already know all this stuff. UDFs is like you can only do it in C for right now. I know they're working on PHP, Perl, and Java, and they're working for native language stuff, but it's not quite there yet. So the way to look for MySQL unencrypted data streams is to basically use TCP dump, and this is kind of assuming you have TCP dump in your path. ETH0 would be your Ethernet device. So on Solaris it's always something different and all that kind of stuff. Here you have the source or destination port 306. So if you're not on 3306, then you want to change that, and then pipe that into strings. This is obviously a Unix command, where strings will just get you the text that's in that, and then you can see if you're seeing select statements or whatever, then it's unencrypted. If you're seeing a bunch of gobbledygook, it's encrypted. And that's it. So other ideas, we already said UDFs. Anything else? Anything I forgot, except for, of course, snazzy code examples that you can all take home and use yourself on all that kind of stuff. I think it was explained pretty well, how to do things like cross-site scripting and stuff that you don't necessarily need.
Maybe to look how other databases do similar thing. Like first, of course, Oracle, and it is kind of inconvenient. Yeah, very Oracle difficult to privileges and all of that stuff is tough.
Oh, one thing I didn't mention actually, or Postgres, like
Yeah,
you were
Postgres
saying.
definitely.
One thing I didn't actually mention is, even though it's locked down by default, you want to check the MySQL replication, where it stores its replication information, because everything's stored there in clear text. The username, the password, the host, and where the server is. So when you do like show slave status, that kind of stuff. I forget what it's called. I think it's called like repl.info or something. I forget what the replication information thing is called, but that's stored in plain text. Now, it's default, it's only readable by the MySQL user. So by default, it's locked down. But you just want to make sure that again, who can see that? You want to make sure the only people that can see that are other thing. But it comes in handy when you've forgotten the replication password after months and months and months of things replicating smoothly, and then all of a sudden, oh, you know what? I want another slave. Oh, what's the password? I have no idea. Well, it's stored in plain text. So.
You would also argue if you want, if you have a database which you're not going to want replication, and you compile and recompile it, you need the replication capability out.
You could recompile, leave the replication capability out, but if you don't ever turn it on or change the master, then it won't ever be stored.
Well, but it's an extra way for someone to compromise your machine so that they can get your data.
Only if you actually start replication.
If they compromise the machine, they get access to the replication to that file.
They wouldn't have the file unless you already had replication on it. You have to put that in the configuration.
You configure it.
Yeah. So, yeah, I guess if you configure it as a slave and then stop it and never want it to come up again, but don't delete the file, yeah, I mean, there's some random way, but yeah. Alrighty, that's all I have. We're early tonight, it was, an hour and a half or so.